Welcome. I'm here to talk about Rust language. My name is Adrian Panicek. I'm senior embedded software engineer at Ciklum Bratislava. I have 12 years of experience in programming, and I think you will find this really interesting because if you have any experience in any programming languages so far, this will be fascinating for you. Okay, what is Rust? Rust is, basically, you can read this all out of the slide, but it's like a ahead of time compiled language. It's cross-platform, it's open source, it's high performance, it's built on LLVM, and it's broad level. What is broad level? Broad level, when we're talking about language, we're talking about low-level languages and high-level languages. What are low-level languages? We always imagine something like assembly, or C, or something like that. Something that is like really hard to code on, but it runs really fast. And then on the other side, we have like a Java, or JavaScript, or Python, or other interpreted languages that run slow, relatively slow, but it's really easy to prototype on. It's really really easy to code on. We have package managers and everything around it. But Rust can run really low code and also have like high-level syntax, so it runs really good. Okay, what is like the timeline of Rust? Because I believe not many of you ever heard of the Rust. Have you ever? Who didn't heard of the Rust language? Until today? Is there anybody who haven't heard about Rust? Okay, one back there. Okay, basically, it began as like a pet project for Graydon Hoare and in 2006, and it was released in 2011 when Mozilla stated basically it's ready to go full stable, and since then it is slowly gaining adoption by various companies, various big projects such as Linux. We have already Rust in the Linux kernel. Okay, let's Rust. I'm sorry, this is my English language potion. Okay, this is the basics. If you know this, you know all the languages. You know how to print hello world right now. What you can notice is like this beautiful short notation for the function. Basically, you define fn, then you state the identifier for the function, and then we use something like this. This is called a macro. It's not really a function. We will talk about this later. And just in simple brackets, we'll print out hello world. Okay, what about variables? Variables are defined by the keyword let. We'll pass number 5 into the x, and we print out the x using println. As you can see, this is like a formatting format, like you can paste something in it to the identifier of the variable, and we do it to print out its value. Then we can override it and then print it again. No, I'm kidding, we can't. Because all of the variables in the Rust language are by default immutable. We can't change them. The compiler will tell us this. It doesn't look really readable, but it's really readable. The compiler in this language will hold your hand. It will tell you, no, you can't do this, but this is a way you can do this. You can specify the x as mutable. We're using let mute, basically like this. Now this code will work because it's mutable. There are multiple benefits of having like structures and variables immutable by default. Okay, now we have it mutable. We have a file written in there, and then now we want to write a Ciklum inside this variable. Yeah, basically, this will not work again. Why? Because it was an integer at first, implicitly defined integer, and then it's overwritten by the Ciklum keyword, or by the Ciklum value. No, we can't do that because compiler will not like us. So we have like implicit types, and we can explicitly specify the type of the variable by defining like what are these called? Not a semicolon. And then a specific type. You can see this is really beautiful. This is by default f32 float 32. We can see the size of the variable. We can see what type it is. We can see like boolean. We can see i32. We don't need to specify uint64 then -t, whatever. It's simple, it's beautiful, it's nice. Okay, now we need to guess what is the type of this specific variable. It's 5 minus 0.5. I apologize in advance that I'm really going really fast, but it has like 60 slides, so I need to go fast. Okay, it's a compiler error. Who guessed? Okay, why? Because the 5 is integer, 0.5 is a float. Don't sleep on my presentation, please. Okay, how do we call functions? We call functions by some, basically the same thing as in any other language. We use this under identifier with brackets. We paste in any parameters we need to get inside. No, this is a catch. This is not a compiler error. This will actually work. And we can do this also with the multiple parameters like x and y, and we specify the types similarly to the variables. Okay, and also now we have a new syntax, and this is a return type denoted by this arrow. Okay, how do we control flow? Like how do we use ifs? How do we use whiles? It's the same as in other languages, except we don't need to use brackets around if. We can just specify it without any other syntax. We can just say if number is less than 5, this will basically run, and it will print out the condition was true. Yes, exactly. Okay, loops, very similar to ifs. We'll just use while, very similar to any other languages, and we can increment this value by, or decrease the value by 1, and print out the number each time it will loop. Okay, we have a new syntax. This is basically a loop. Loop runs without it's like while true, but it's a little bit nicer. Okay, for this is also same as as in other any languages. We can iterate over elements of a certain array within for and in, and then we have like the element inside, or each element in each iteration will be its value. It will be in this element identifier, and it means we can print it out, or we can use 1 to 4. This is a range specifier. Those who know how to code in Python will don't know this language, and we can reverse it and print the numbers from 4 to 1. Nothing fancy. Okay, now this is the hard part, and this is ownership. Because this is new concept. It wasn't implemented in any other languages, and basically, if we specify something like a string, this is how we can specify string in a heap. This is specific value. We'll talk about it later. And then we'll try to pass it into another variable like S2. We have it in S1, and try to pass it to S2. It will crash. Because once we pass it to S2, the owner of this value is the S2, and the S1 value is basically discarded. Okay. Once we try to print in S1, it will crash. No, it will not crash. It will not allow to compile. Okay. But this is basically what the compiler says. As I said, the compiler always holds your hand. Okay. How do we fix it? We can clone. We can clone this value, but this clones the whole value. Like in both of these strings is the heap allocated string hello, and this will print. This will print basically the same. Maybe okay. Let's try it again. What if we define the variable s, then pass it into another function, and we try to print it? This will work. This will work just fine. But once we try to pass it and then print it in the same scope, no, it's not valid. This will throw and basically it won't compile again, because the value of this s was already passed into this function. It's really advanced concept. I'm not sure whether you will get it, but why do we do it? We'll explain later. Okay, the next thing, borrowing. Borrowing is same as the referencing, or we could call them pointers. Basically, this is a reference to this value. We denote it by this ampersand, and we denote the type is ampersand string, and basically it works the same, but we're not owner of this value, and we can only read it, not modify it. And now we can print it, and then print it again, and this passes the value and basically and its ownership into the macro println. And we can also make it mutable, so we can pass in mutable reference, or there are some caveats with that, but yes, we can also pass the value into another function, then modify its value, and then we can do anything with it, whatever we want. Okay, this is basically a simple slide. Yeah, I wrote half of these slides like one drag and night, so sometimes I'm as surprised as you. This is basically we can't mutable borrow the same value twice. This is exactly what the compiler says. And why do we use this ownership? Okay, so this is like the big thing, because this is why the Rust is popular. You can see some of the screenshots of really why do we want the ownership? Because C is not memory safe. We use C, C++ everywhere, yeah? And we have a lot of bugs because of the unsafe or free after use, or use after free, or I don't know, or memory leaks or whatever. This is not only like a bug issue, this is also security issue. This is why many companies and government agencies are trying to push Rust into their platform, because we can avoid most of these bugs. Oops. No, I'm just kidding. You can utilize here. Okay, how do different languages manage memory? Basically, in C, C++, we manage it manually. You can see, you use memory alloc, malloc, and then you will use free to free the heap. And yeah, if you forget it, it's your problem, but it's also it also can be like $1 billion issue. We can use also garbage collector, like in Java, Python, or JavaScript, or on the other interpreted languages, or example Go. And this will like dereference and delete everything that is like out of scope. We don't use it anymore. It will be deleted from the memory. Okay. Then we have reference counting and smart pointers, which is like really smart idea introduced into C++, which means we define what is the ownership of this value. We say like maybe it's a unique pointer, and we say, okay, we can have only one reference into this type. And if it goes out of scope, we'll delete it. You can't reference it again. Really smart. And ownership model from Rust takes it to another level. It will apply this idea of RAII into every aspect of the code. This is like some of the examples of issues that were caused by C++ or C or manual managed memory. And these are just examples. If you want to go into like a list of exploits or like security issues, and you'll just write in a random number and you hit enter, it's like almost 40 to 70% chance you will hit something that is related to memory safety. Okay, this is Heartbleed. Most of you don't remember probably. It was a big issue where you could like ask from any machine running SSL, you could request all of the values from the memory just basically by typing in a higher number. And these are some more examples. I won't go through each one. It will take a long time. But this one, the last one, is really interesting. This is the one why I had to change this presentation, because this was discovered 2 days ago, and it's a 0-day exploit at Firefox when you could specifically modify CSS language and will gain remote code execution over a system that runs Firefox. It was discovered, as I said, like 2 days ago. So that means CSS is now officially hacker language. This is an example of unsafe memory operations in C. I will take more time on this slide, because some of those who know how to code C try to get what is wrong with this code. I want one person, at least one person, will find a bug in this. Again? Yes, this is the language. Yeah. Yeah, it's the issue. It's a C language. That's the biggest issue. Nobody? Okay, basically. Yeah? Anybody? Try to tell me what is wrong with this code. Yeah, the source is called, the memcopy is copying 7 bytes from the source, and what happens is, yeah, this is 7 characters long, but we don't copy the termination character, the 0 character at the end. Yeah, this is bug. Also, this is bug because the order of parameters is wrong. So this means we'll copy basically 7 characters, and we set the 7 characters into the copy into value 0, but it's wrong because instead we set a 7 into 0 characters because the parameters are swapped and nobody noticed. Yeah, there is a use after 3. Yeah, the comment says it, and there's like 4 bugs in this code. Maybe you'll find it later. I'll share the presentation, but no one notices this. Even like really experienced C programmers will miss most of this code, most of these bugs, and there are multiple examples, not only in Linux, also in the graph, also in Windows, everywhere. Okay, how do we do data structures? This was a hard topic, and there's a reason why we need to do Rust. This is how do we do Rust again. So Rust isn't traditionally OOP. It is OOP, but it doesn't have classes and inheritance as we know it. It uses structs, okay? Well, this is a similar concept to C or C++. Basically, we define some of the, we can group variables into one struct. Yeah, that's not one object. It's not like mind-blowing idea. How do we initialize it? We'll define the object by defining the struct and passing some of these values. We can pass it in the shortened syntax. Yeah, that's fine. It's everything that you can read in the manual in 5 minutes. Nothing that interesting. Okay, how do we define methods on these set structs? We use impl. IMPL basically can define the functions as we specified on the first slide. And these functions will be only within this struct. And how does it relate into the set struct? It says like it's rectangle. It implements the functions onto the rectangle, and then it takes reference to self. And this is a special syntax for Rust. It takes reference for self. This is something similar as this, except we can say, okay, we take this by reference. We can take this by value and claim its ownership, or maybe we don't want to take reference to self at all and this makes it automatically a static function. I hope there will be example for static function, but there's not. Okay. So as I said, this will calculate the area by multiplying width and height. And this is how we call it. We will just call the rectangle area. It will print out the area. It's now nothing mind-blowing. Okay, just a syntax. Okay, and this is how do we create these static constructors or static functions. We don't want the reference to self. We'll just pass inside. We'll pass in 2 values of rectangle and height. And instead of constructing the rectangle by like this, okay, we can use now function, rectangle new. This will basically do the same. It's denoted similarly to C by this syntax, and it will construct a new object of the value rectangle, and we can print out its area. Nothing mind-blowing. Okay, these are traits. Traits are something like interfaces in other languages in Java, or it's or abstract classes without definition in C++. And it's something that doesn't contain data itself. It contains a contract. How do we implement something? So we can define like a trait of summary, and we can then have summary implemented into news article. Okay, we say implement summary for news article, and this will force us to define the implementation of the function summarize, or as this requirement, this contract says. All of these examples are taken from the Rust book, and it's like really good material to read about Rust. How do we call them? This is a little more advanced topic. This is basically how do we say, okay, we take anything it takes summary. There are multiple methods to taking anything that implements summary. We can just say it using templates similar to C++. We can say it using impl, basically means whatever implements summary. There we can take it as a parameter, and then we'll call summarize on top of it. Also, we can chain these specifiers or restrictions. Maybe too much English language juice. And then we can chain it and require not only implement summary, but also the value that comes in this item. It needs to also implement a display trait. Okay, enums. Enums, this is for most of the languages, enums are really boring, but not in Rust. In Rust, yeah, this is basically the same. We can define IP type of v4 or v5 or v6, I'm sorry. And then we can specify, we have IP type v4, nothing groundbreaking, and we can have match statements on top of them. We have like a shapes of triangle, square, hexagon, and we try to get corners of the number of corners of the set shape. And the triangle will say 3, square will say 4, hexagon will say 6. Nothing groundbreaking, but then if we exclude the hexagon, this match, pattern matching, will say, no, you're not allowed. You need to define what happens if the value is hexagon. If you can see here, yeah, we only specify the return value for the triangle and for the square, but not for the hexagon, and compiler doesn't like it. We need to specify what happens in case of the hexagon. Also, that means the enums are exhaustive. We always need to take into account all of the cases, and we can also implement values in the same fashion on top of the enums. So we can say shape can have function corners, and you can see it here, and then we can get the corners of the set shape. Okay. Now, this is the powerful part, enums in the Rust. This is maybe hard to get on the first try. Enums in Rust can have values. Basically, we can pass value inside set enum, yeah? We can say, okay, this is a rectangle, and this is other polygon, yeah? And the other polygon also contains a value of how many corners it has. It's not, I guess this is not the best example, but if you, does anybody get this? Okay, at least half, that's good enough, I guess. How do we use it in practice? And this is the practice. This is one of the most useful concepts coming from the Rust, and it's option. Okay, option is an enum that has like that can have two values, and it's none and sum with a t. And sum with a t means it carries some value of a type t, which means we can, thanks to this simple construct, we can avoid all of the null pointers. We don't have null pointers in Rust because there are $1 billion mistake, as said Tony Howard, who originally was a creator of a null pointer, but yeah, he regretted it his whole life. So how does it work? We can use a nice function called iter, which creates an iterator, and then we can call end, like the number of element, and this will basically get the second element because yeah, it says number 1 while we index the elements from the arrays from 0 because we're not savages, and this will basically return, this whole statement will return an option with a value of string because this is an array of string. And this means we need to break it out somehow. And in a similar fashion as in, basically even here with the shapes, we need to break it out and we'll say if it contains sum, if the value is sum, it has inside value user, then we can print it out using println. And if it's none, we will just print out unknown user. And this saves us from all of the null pointers because each time you have a need to use null pointer, we'll just use option. Oh, Yeah, this is basically a safely implemented divide by zero, because it says if this is a function that divides the A by B and returns an option of F32. If the value of B is 0, well, we can't divide by 0, it will return none. And if it's any other value, then we can return A divided by B, and we can basically, this whole statement represents the option F32, and and as I said before, all of the enums can have its own functions inside. We implement this expect, which basically means if we don't have a sum value and we have a none, it will panic and it will crash the whole program and print out this message. If it has, this returns the value inside the sum. It's a nice, useful syntax something. Okay, let's talk about unsafe. Okay, unsafe. All the time we talked about how the Rust is safe, and we need to make it sometimes access pointers or something like that. We can use it using this unsafe block. We can just access, basically do anything we need to do like inside of C language. But now the compiler won't scream at us and it will actually compile. But we need to make sure that this is actually a safe code and not any garbage that can cause runtime issues. Okay, this is like one of the last parts. This is what I skipped, and it's like a half of this, half of the language, half of what is important, and it's like in 25 minutes. So I skipped lifetime referencing, cargo, package management, macro system, integrated unit testing, slice types, generic types, closures, smart pointers, and fearless concurrency. This is where you can read all about this. This is an official book from Rust online that you can read, and it's fantastic. It's all you need to know about the language, and there are some also other references. And here's a little demo project. If you are on this Wi-Fi, open this link. Okay, do it please now on mobile phones or anything. Okay, do it please now. If you have a mobile phone connected to this Wi-Fi, just open this. Yes, all of your logins are mine now. So basically what it runs, this is a thank you slide. What I'm interested in is this demo. And I can show you the slide again, but the IP address is 10.25.100.171. And this is all implemented inside the Rust. There is a source code on this link, and this chat server runs on this little toy, which is ESP32C6, and it's really small toy to play with.